Hello students, in this video we're going to talk about how vector can be used to describe displacement or velocity. And as you can see, they are fairly similar, but there are some subtle differences between them. So a displacement vector generally describes the information like where am I in the coordinate plane, okay, in relation to the origin, for example. Also, it can be used to describe where am I relative to some reference point, and generally that is where I'm starting from. Whereas a velocity vector would describe the kind of information like where am I going to be sometime later. Okay, so let's use an example to illustrate these differences. Let's take a look at an example. So let's say I have a starting position 2, 3, and after a displacement vector of -3 and 4, where am I now? Okay, so let's plot out where our starting point is 2, 3, as I've indicated here. And my displacement vector being -3 and 4 means that I'm going to go -3 in the x direction, and then 4 in the y direction. So which means this is the direction of my travel. So where do I end up? Well, it's going to be at -1 units in the x direction, and then it's going to be at 7 units in the y direction. So the answer in this case is -1, 7. How about if we change the problem a little bit? Let's say instead of starting at 2, 3, now I start at the origin. Okay? And I use the same displacement vector. And after that, where would I be? Well, if I start at origin, which is right here, and I use the vector -3, 4, 3 units this way and 4 units that way, then I'm going to end up at that place, and I'm sure you can figure that out. So that's going to be just -3 and 4. Okay, so if you start at origin, the displacement vector would exactly bring you where your final point of location is. Let's take a look at another example. So let's say I'm going back to position 2, 3. So this time I'm still going to start at this place now, 2, 3. But my travel vector is 1, 1. But it's at every minute. So in other words, I'm going to go the direction of +1 unit in the x and +1 unit in the y. But every minute, I'm going to increase that vector by the same units. 1, 1. So every unit, I'm going to go 1, 1, 1 over to the right and 1 vertically. After 5 minutes, where am I going to be? Well, I should be right here, right? After 5 minutes, I would have traveled 5 units in the horizontal direction, and I would have traveled 5 units in the vertical direction. So my final point of location would be 7 and 8. Okay, and this is my final location at 7, 8. All right, so let's summarize. If I use a displacement vector, let's say of a variable d1, d2, and then a velocity vector, let's use the notation of v1, v2 for its 2 different components. Then velocity vector is generally expressed in terms of this vector per unit time. So it could be over a second, over a minute, or over an hour, depends on how the problem is structured. And if my starting point is a, b, and similarly here, if my starting point is a, b, then my final location in the case of displacement vector would be simply a plus d1 comma b plus d2. Okay, and you can also write it in the vector notation, which is a comma b plus d1 comma d2. Okay, the two entirely equivalent. Okay, but in the velocity vector case, what happened is that your starting position A, and then you would be adding v sub 1 times t. That would be the final x location, and then the final y location would be b plus v2 times t. Okay, again, you can also write it in the addition of two vectors, so a comma b plus t times v1 comma v2. Okay, again, these two are equivalent.